morning, everyone. Thank you for attending our second TAG meeting and thank you for being here. So my name is Duygu Yasar. I'm a graduate student in Industrial Engineering Department. And our team, SimLab Research Team, has two other members, Haluk Damgacıoğlu and Merhat Bastani. We are all working under the advisor of Dr. Nurçin Çelik. So here is an outline for what we are going to cover today. First, I'm going to talk about what motivated us to conduct this study and how we collected our inbound contamination rates and outbound contamination rates, how we analyzed them, both inbound and outbound contamination rates. And I'm going to also talk about mixed waste processing facilities for potential future studies. And then we are going to discuss our findings. So Florida's waste generation was 32.5 million in 2015. And the population is expected to grow by 1.2 million by 2020 in Florida. So it's known that there is a positive correlation between the population and waste generation amount. And also, on the other hand, there is the recycling goal set by Florida to be achieved by 2020, which is 75% recycling goal. But now, currently, the recycling rate in the state, it hovers around 42%. So the community started to switch to single-stream recycling to collect more recyclables. Currently there is 50% of the population, they have access to single-stream recycling, and some counties switched to SSR recently. In recent years, Miami-Dade, Broward, Leon, and you can see some of the biggest counties, their recycling rate with the green bars on the graph. So what is single-stream recycling? It's the collection of recyclables in a single bin with single compartment trucks. It has advantages over other systems like DSR, dual-stream recycling, and it has also disadvantages over other systems. So it reduces the number of trucks on the road because the trucks, they don't have to have multiple compartments, so they can collect more recyclables at a time. So that's why it reduces the number of trucks on the road, and also it reduces the collection costs of recyclables. It's also claimed that it increases the amount of recyclable collected from the communities because people tend to participate more in the recycling activities since it's easy for them to just throw out everything in a single bin instead of sorting them in separate bins. So there are also disadvantages of this system. So the first one is it's claimed that it increases the contamination rates, which is the unwanted materials in recyclable materials. It's also claimed that it lowers the quality of the recovered materials due to the high contamination. So due to this high contamination, the recovered material facilities, they need a greater need for raw material to replace these rejects due to the high contamination. It also increases the processing and the maintenance cost of the facilities. So here there is a process flow example of single-stream paper recovery operation. There is disk screens, scalping screen, manual sort along the way until it's sorted out into different paper grades. So there are challenges faced by the implementation of single-stream recycling. Okay, recovered materials, those are valuable commodities that are sold to processing facilities and manufacturers to be used in their processes. But high contamination decreases the quality of these materials, and also it decreases the average revenue generated per hour of production for MERS, for material recovery facilities, MERS. So you can see from this graph that as the contamination rate increases, the revenue per hour of production generated by the MERS, it decreases exponentially. So this contamination issue needs to be further investigated to see if single-stream recycling really increases the contamination rates, or they really increases the amount of recyclables collected in the communities. So that was the reason that we conducted our study, and we also focused on the paper, recovered paper in the outbound stream. So we collected our data from multiple sources, counties. We contacted all 67 counties in Florida, 7 currently operating industrial facilities, American Forest and Paper Association, Florida Department of Environmental Protection, and United States Environmental Protection Agency to collect our data. And we did 2 site visits to 2 operating facilities in Florida. So at the end, we had 15 recyclable composition studies to retrieve the samples, material composition samples, and also 6 recovered paper outbound audits. So here is the steps that we have taken to conduct our study. We first collected the inbound data from MERS and counties, and then outbound data from MERS, again in their outbound stream, and paper mills and paper processors. We compared the inbound contamination rates in SSR and DSR to see if there is a statistically significant difference between them. And then we compared the reject rates, contamination rates in different waste generator sectors like single-family households, multi-family households, and commercial sector to see which one was the most problematic for SSR. We calculated the adjusted recycling rates. It's the recycling rate when we take the contamination rates into account. We're going to talk about it further. And finally, we analyzed the outbound contamination rates in recovered paper for different grades of paper like ONP, old newsprint, and old corrugated containers. So inbound contamination rate is the contamination in the collected recyclables from communities, and outbound contamination rate is the contamination in recovered material, in the bales of recovered material after they are processed in MERS, in material recovery facilities. So here is an overview of our data. Inbound contamination rates, you can see that DSR has a lower mean of contamination rate than SSR systems, and its range is SSR's range is wider than the DSR systems. And in terms of the outbound contamination rate audits, we found that based on our data, 67% of the ONP, old newsprints, was acceptable by the paper mill standards, and only 91% of the OCC was acceptable by the paper mills, and the rest was outthrows, prohibited materials, and brown paper for ONP. So ANOVA, analysis of variance, was what we used to analyze the inbound contamination rate. It's a statistical technique designed to compare the means of different populations. So in our case, it was single-stream recycling contamination rates and dual-stream recycling contamination rates. So we first did the normality test for our data to see if it's really a normally distributed population, and the results were positive. So we could further analyze data using analysis of variance, because populations being from the normally distributed data, it's the assumption of ANOVA. So we have to test this first. And our results, ANOVA results, showed that we could reject the null hypothesis, which means that there is a statistically significant difference between the contamination rates of the two systems, DSR and SSR. So which one was higher? You can see here in this box plot that SSR has a higher mean and higher minimum value and higher maximum value than the DSR contamination rates. So this was the analysis of inbound contamination rates. And then we further analyzed the waste generator sectors to see which one was the most problematic for the two counties that we contacted. And Haluk will present these two for you.
Thank you, Duygu. Welcome again. I am going to present one part of our study in this project. And as Duygu mentioned, we found that in from our analysis, SSR increases the contamination rate in the inbound stream compared to DSR. So then, in order to provide a better understanding of the contamination rates in the incoming stream, we conducted this analysis. In this analysis, we compared three waste generator sectors, which are single-family residentials, multi-family residentials, and commercials. Here, we selected two comparable counties, which are County A and County B. As you can see in the descriptive statistics as shown in the box plot, single-family residentials have the highest reject rates, while the commercial sector has the lowest reject rate. Then we conducted ANOVA and concluded that there is a significantly difference between commercial and single-family residentials reject rates, as you can see in the multi-compare t-test. So based on our results, we can conclude that County A should more focus on educating single-family residences, and they can provide some outreaches for the single-family residentials. In the other county, we applied the similar analysis, and then based on the descriptive statistic, as you can see in the box plot, unlike the County A, in County B, the multi-family residentials provide the highest reject rates. And also here, the single family generates the lowest reject rates. Then we again conducted the ANOVA to see if there is a difference between these sectors. And as you can see in our multi-comparison test, ANOVA accepts the null hypothesis. It means that no groups have means significantly different from each other. So based on this analysis, we can say that County B should more focus on more generic educational plans or programs that includes all waste generator sectors. And also, when we compare County A and County B, we can easily say that County A generates much higher reject rates compared to County B, so they have to focus on more educational and direct assistance or incentive programs to decrease their contamination rates. And more importantly, here we show that each county has different characteristics, and then they require different programs to reduce their contamination rates in paper recycling. Now, Duygu will continue our other studies analysis on inbound and outbound stream.
Thank you. So that was the analysis of Haluk on waste generator sectors. So different waste generators might be more problematic than others in different counties, as you can see from our analysis. So furthermore, I did an analysis to calculate the adjusted recycling rates of the counties that use single-stream recycling. So here the recycling rates of those countries that was published in 2015 by Florida Department of Environmental Protection. And here are the contamination rates of those counties and the adjusted recycling rate after we take out the contamination rate from these recycling rates. I wanna show you these two counties, the first county and the third county. As you can see, the recycling rate of the first county was the highest, 58%, and the third county was 51%, lower than the first county. Contamination rate of the first county is 28%, and the third county is 7.6%. So after we calculate the adjusted recycling rate, we see that the third county actually has a higher recycling rate than the first one. So actually, considering only these recycling rates without considering contamination rates or making analysis on contamination rates, it might be misleading when it comes to 2020 and when the states want to see the counties that reach the 75% recycling goal. So those issues were the most important ones that were faced by those single-stream recycling counties that we contacted. They experienced a large number of plastic bags filled with municipal solid waste in their single-stream recycling bins. And they also experienced a wide range of municipal solid waste from used diapers to food trash, like everything placed in the single-stream recycling bins. And one of the most problematic recyclable material was the paper products, and they said that they were saturated with water and degraded in the recycling bins. So we further wanted to see how the paper recycling rates changed in these three counties that switched to single-stream recycling around 2008 and 2009, Broward, and Miami-Dade. So as you can see, the newspaper recycling rate started to increase after 2009, but mostly after 2012. So it took them around like 2-3 years to adopt a new recycling program entirely and increase the amount of recyclables that they collect from the county. So in terms of the other paper, it has a slightly lower increase than the newspaper. Broward, they experienced the increase, but in Miami-Dade, actually you can see a decrease in the other paper recycling rates. So single-stream recycling might not always result in a higher amount of collected recyclables from the counties. Every county should analyze their system and see where the problem is and try to fix it. So here is the analysis of outbound contamination rates for ONP, old newsprint. So these are only 50 samples of our entire data set because it was too much to show in a clearer way to you. We randomly sampled 50 of it. There are brown paper, which is contamination in old newsprint, outthrows, which are other types of paper grades that are not supposed to be in that specific paper grade. And also there are prohibited materials, which are the other recyclables like glass, plastics, metals, these kind of materials. So the red lines, they show the accepted limit by the paper mill. And the green lines, they show the mean contamination rates of these samples. As you can see, the outthrow contamination, mean contamination rates, and prohibited material mean contamination rates, those are higher than the accepted mill limits, and almost all of the samples, they are above the accepted mill limit. And in brown, in terms of the brown papers, the mean is actually below the limit of the paper mill, but there are also some data points that are higher than what's accepted by the mill. So I want to say here that, okay, prohibitives are glass, metal, and plastic, recyclables that are not actually paper, right? So if it was a dual stream recycling system where you have two separate bins for paper and for other recyclables, they probably wouldn't have this much prohibitive materials. So this is what I want to say. This is kind of like a difference between the dual stream and single stream, and you can see it results in a higher rate of prohibitive materials, which is not accepted by the mill. Like there is 4% difference between what the mill accepts and what's the actual rate is. So also we did the same analysis for old corrugated containers, another paper grade, and red lines again what's accepted by the mill, and the green lines again what's the mean rate. So prohibitive is again higher than what's accepted by the mill, and outros they are lower than it, and there are some data points higher than what's accepted by the mill. And here, like most of the data points are actually higher than the limit of the mill. Again, if we had a DSR system, we wouldn't have this much prohibitive materials because we don't mix the paper and glass and metal and everything in a bin, in a single bin. So we further wanted to see the bigger picture. So we collect the OCC and OMP, and then we send it to MRF, and then MRF does the processing and send it to paper mills, bale it and send it to paper mills. Okay. So this is the average recycling rate of, not recycling rate, but what's recycled from what they receive from the counties in a single stream recycling system in Florida. We calculated this by taking the average of the single stream contamination rates of the counties that we actually collected data from. So the average contamination rate was around 20% for all of them. So they collect the recyclables from county, but actually in the inbound only around 80% of it gets recycled. And then MRF processes it, and only 67% of it can be usable by the paper mill. So we end up actually getting a recycling rate of 54% of what we received from the counties. And for OCC, it's 74%, around 74%. So I guess it's not a good idea to say that we collected this much recyclable material and we recycled this much. It's not like, it doesn't work that way. We take it and we still sort the contamination out, and we send this contamination to the landfills, and they are not recycled. So we have to actually think about the rest of the life cycle of these recovered materials too, not only until we collect it from the communities. So this was pretty much our analysis on our inbound and outbound data. And there is also one more subject that I want to talk about: mixed waste processing facilities. This can be a subject of a potential future study. In Florida, for example, contamination rate in recovered paper from single stream recycling and mixed waste processing facilities, they could be compared to see how worse it is in mixed waste recovered paper. But it's kind of challenging because the great majority of the paper recovered from mixed waste MRFs, they are exported, and so we don't actually have that much available bales to sort out and to see what the contamination is. And also there is a lack of mixed waste MRFs in Florida. As you can see, this is the list of mixed waste MRFs in United States, and most of them are in California actually. So I want to end up my explanation about mixed waste processing facilities with the study conducted by Institute of Scrap Recycling Industries. So they reached out 153 paper mills to learn, to see what their perceptions are about the recovered paper they received from mixed waste MRFs. And 41 paper mills, they responded to their request, and 25% of the respondents, they said that they receive recovered paper from mixed waste MRFs, about 10 paper mills. And 70% of those respondents who purchase recovered paper from mixed waste MRFs, about 7 of them, they find its quality worse than what they receive from other systems like single stream, dual stream. And they actually rank the reasons for not purchasing mixed waste recovered paper, and the number one issue was the contamination, high contamination in mixed waste MRFs, and also low quality due to this high contamination, non-acceptable rates of prohibitive and outthrows, internal quality standards, and too risky to use because this contamination, like for example prohibitive materials glass, it poses danger both to the equipment of the paper mill and also to the employees who work there. Excessive moisture from food waste and trash, and lack of availability of the mixed waste MRFs in their area. So our research team, it has 3 graduate students and 1 undergraduate students. We all are working in the research lab of Dr. Nurtin Çelik. Thank you so much.